Introduction of integration. Integration is the process of finding the whole from the parts. It is the opposite of differentiation, which is the process of finding the rate of change of a function. Integration can be used to find areas, volumes, displacements, and other quantities that are related to the sum of infinitely small data. There are two main types of integration, which is definite and indefinite. A definite integral gives the area under a curve between two limits. An indefinite integral gives a function that has the given function as its derivative. To find an indefinite integral, we need to use the rules of integration, such as the power rule, the product rule, the chain rule, and so on. To find a definite integral, we need to use the fundamental theorem of calculus, which connects the concepts of differentiation and integration.
Okay, on this slide, I'm going to talk about the example of application of integration in real life. First and foremost, in physics, integration is used to calculating the work done by a variable force. By integrating the force with respect to displacement, we can find the total work done. Secondly, in biology, integration is used to modeling population growth. Integration is used to calculate the cumulative effect of birth and death rate over time. And for the lastly, integration is used to determining the area of irregular land masses. And also, integration can be applied to calculate the total land area from irregularly shaped plots. That's all for me.
Question 5. Y equal to square root of x. Y equal to x power of 2. Rotating around the y-axis. Number 1. Find coordinate x of the intersection between y equal to square root of x and y equal to x power of 2. Square root of x, we use the y1 and square, and x power of 2 we use y2. y1 equal to y2, put the value for y1 and the y2. For the y1, square root of x equal to, for the y2, x power of 2. Open bracket, square root of x, close bracket, power of 2 equal to, open bracket, x power of 2, close bracket, power of 2. X equal to x power of 4. Power of 4 minus x equal to 0. X, open bracket, x power of 3 minus 1 close bracket equals 0. And the final answer, x equals 0, x equals 1.
For step 2, we have to find the value of y. So to find the value of y, we have to replace the x value in the original equation, which is y equal to square root of x and y equal to x squared. So when x is 0, we replace the x here, and eventually we will get y equal to 0. And then when x is 1, we replace the x here, and eventually we will get y equal to 1. So finally, graph y equal to s square root of x has 2 points, which are 0, 0 and 1, 1. And for the equation y equal to x squared, we do the same. We replace the x value, and eventually we will get y equal to 0. And when x equal to 1, we do the same, and eventually we will get y equal to 1. So finally, graph y equal to x squared has 2 points, which are 0, 0 and 1, 1.
In this step 3, we want to find the volume when the graph is rotated around the y-axis. Okay, first we formulate the formula. We make the formula first, and this is the formula. Pi integration sign from 1 to 0 x power 2 dy minus dengan pi, which symbol integration 1 from 1 to 0 x power 2 and then dy. First and foremost, after that we need to find the value of x power 2 and this x power 2 also. The first x power 2, we use the formula, we use the equation y equal to x power 2. We must make the x power 2 be the first and then equal to y, and then the same thing for this equation y equal to square root x. We must to put the x first by power all this with power 4, and this side also power 4, and then we get x power 2 equal to y power 4. After we get what the x power 2, what the value of x power 2, we just put the value of y into this equation, this formula, and this is the result we get. Pi integration sign from 1 to 0 y dy minus pi integration sign y from 1 to 0, which and this y power 4 and dy. All we need to do now is integration. Just integrate this y. As we know how to integrate, we just put plus 1 in this power 1 become 2, and then we divide by 2, and the value 1 0, so we put 1 0 minus dengan pi, which we integrate this we 4 plus 1 we get y power 5, and then divide by 5 and divide by 5, and then we get this, and then put the 1 0 on this side, on this bracket, and then we just settle it, and we get this answer, pi bracket 1 power 2 divided by 2, and then minus 0 power 2 divided by 2 bracket minus pi bracket 1 over 1 power 5 over 5, and then minus 0 power 5 over 5, and then bracket. Then we just solve it. We get 1 over 2 pi minus 1 over 5 pi, and then we minus this, we get 3 over 10 pi unit 3. This is in okay, we get the answer this in fraction, and if we want to find in decimal, we get 0.3 pi unit volume, pi unit power 3.
Question C. Y equal to square root of x, y equal to x power 2. Rotate around the x-axis. Number 1. Find coordinate x of the intersection between y equal to square root of x and y equal to x power of 2. y1 equal to square root of x and y2 equal to x power of 2. y1 equal to y2 and put the value square root of x equal to x power of 2, open bracket, power, open bracket, square root of x, close bracket, power of 2 equal to, open bracket, x power of 2, close bracket, power of 2. X equal to x power of 4. Power of 4 minus s equal to 0. X open bracket, x power of 3 minus 1 equal 0. And the final answer, x equal 0, x equal 1.
For step 2, just like question 5, we have to find the value of y. And just like question 5, we have to replace the x value in the equation y equal to square root of x and y equal to x squared. So when x is equal to 0, we replace the x here and eventually we will get y equal to 0. And when x is 1, we do the same, we replace the value of x here and eventually we will get y equal to 1. So finally, graph y equal to square root of x has 2 points which are 0, 0 and 1, 1. So for the equation y equal to x squared, we replace the value of x with 0 and eventually we will get y equal to 0. And when x is equal to 1, we do the same and eventually we will get y equal to 1. So finally, graph y equal to x squared has 2 points which are 0, 0 and 1, 1.
In this step 3, we want to find the volume when the graph is rotated around the x-axis. And this is the formula of the volume. If we want to find the volume, pi integration sign 1 from 1 to 0 y power 2 dx minus pi integration sign from 1 to 0 y power 2 and dx. We want to find the value of y power 2, so we use the equation of y equal to square root x, y equals square root x, and then y equal to x power 2. This is y equal to square root x. We just make it y power 2 in the first and equal to x by power 2 this side and then this side, and then we get y power 2 equal to x. And next, for this y equal x power 2, we just power it 2 and then x square x power 2, we also power it 2 again and we get x power 4. After we get the value of x, we just put it into this formula and then we get this equation, pi integration sign from 1 to 0 x dx minus pi integration sign from 1 to 0 x power 4 dx. And then we just integrate it. We power 2 and then divide by 2. And same thing for this, x power 4 with plus 1, we get x power 5 and then divide by 5. Then we get this result. By bracket x power 2 over 2 bracket 10 minus pi bracket x power 5 over 5 bracket 10. Then we solve it. We just solve it. We get the answer of this, pi bracket 1 over 2 and then minus 0 power 2 over 2 and then bracket and then minus pi bracket 1 power 5 over 5 and then minus 0 0 power 5 over 5 and then bracket. We solve it, we get 1 over 2 pi and then minus 1 over 5 pi. This the answer in fraction, 3 over 10 pi unit power 3. And if want to find in decimal, we get this 0.3 pi unit power 3.
Summary. In mathematics, integration is a powerful concept that involves finding the accumulated total of quantity over a given interval. Think of it as adding up tiny pieces to determine the whole. The process is like calculating the area under a curve on a graph, where the curve represents a charging quantity. Integration helps us solve problems related to accumulation, such as finding the total distance traveled or the total amount of something over time. It's like breaking down a complex problem into smaller parts and summing them up to understand the overall outcome. Basically, integration provides a mathematical tool to analyze and comprehend the total effect of varying quantity. Thank you.